Okay, so we have done up to point C. Okay, we're going to do point C now. Now, point C is something new that we will learn. Okay, now we're going to do at point C. So what is the new thing is we're going to do the analysis from right to left. Okay, so at point C, where x is equal to L minus A. Now, why I decided to do from right to left is you already see the complicated the amount of factors we have to consider when we do left to right. Okay, so we're going to do right to left. Okay, so now the geometric datum is still on the left hand side. Okay, geometric datum is still on the left hand side. So the distance from here to here, right, is L minus A. Okay, so now when we do our analysis from right to left, we only need to draw this. Okay, so we have a point over here, T. So this is our point D, right? This is our point C. And at point C, we have a force going up here. And this is equal to, let me check, I forget what it is already. This is equal to P plus by omega over 2 L minus 2A. So now our analysis is from right to left, right? Right to left. So when that's the case, we change the direction of the shear force and bending moment assumption. Sorry, the direction assumption is still the same, the direction change. So now this will be V at point C, and over here will be M at point C. Okay, you all can see the switch now, yes or no? Right? You all can now see the switch. So the distance from here to here now is A. Okay, that distance, because now we are at x equal to L minus A. Okay, so now all we have to do is positive shear and positive bending moment assumption again, and we do static analysis. Okay, so we do static analysis. Okay, so positive is going up, summation of forces in the y direction is equal to 0. So you have minus P plus by P plus by omega over 2 L minus 2A, okay, plus by V at point C, answer is equal to 0. So V at point C is equal to minus omega over 2 L minus 2A. Okay. So like what we have seen before, right? Right. So remember when before we went to a break, we calculate this value over here, right? Point C is minus omega over 2 L minus 2A, exactly as what we have come up with. Okay, so we go to our table. So we know that this is V at point C is equal to minus omega over 2 L minus 2A. Okay, and then we do our moment. Okay, so our moment, so I mentioned about moment in the Z at point C is equal to 0. So now where we take our moment, we take our moment here. Okay, so this will be equal to plus PA, right? PA, sorry, minus PA. PA is going in the anti-clockwise direction. Sorry, clockwise direction, and then minus M as a function at point C is equal to, so M at point C is equal to minus PA. Okay, so exactly the same like what we've shown down here also. Okay, so this is equal to okay, which is what we have drawn. So you can see why I make you guys learn right to left analysis. It's so much easier, less factor to consider. Less factor means less mistake. Okay, and then I'm going to use the same page. We're going to do the last section. Okay. So the last section is from point C. Okay, we are going to do from point C to point D, right? So C to point D, so it's L minus A, X to A. Now this you have to be careful, okay? So datum is still on the left-hand side. Now the distance from here to here is X, okay? So again, we draw this is our point D. At point D, we know we have a load P over here. Now this distance from here to here now, okay, that distance that we have just drawn, we know that for the entire beam, right, for the entire beam is L, right? And this has to be L minus X, okay? It cannot be X minus A because X minus A will give you a what? A negative value. So this is wrong. It has to be L minus X, okay? Then positive shear, and then positive bending moment. So you can see that the equation is so much easier. Yes or no? The equation is so much easier to form now. Yes or no? Right? If we were to consider left to right, okay, we're in trouble again. This one we are looking at right to left analysis. Okay, so right to left analysis. Okay, so again, static analysis. I think you all will find this topic simpler, right? After going through shear force, shearing stress, and compound loading. So positive is going up. Okay, so you have minus P plus by V as a function of X is equal to 0. So V as a function of X is equal to P. Okay, so that is our P. So from C to D, okay, C to D, V as a function of X is equal to P. Right, so later on, we will draw wait, where am I now? I think I'm missing a one. Let me see. Yep. So L minus A is a positive P. Yep, it's correct. And then we will do from our bending moment now. Right. So we're going to take our bending moment from this point over here. So now it's going to be in a clockwise direction minus P L minus X, right? And then we are going to have minus M as a function of X the whole thing is equal to 0. So m as a function of x is equal to minus PL minus x. Take out the expression, you will have px minus by PL. Okay. So going back to our table, m as a function of x is equal to px minus by PL. Okay. So now we come back to our table. So at point C, you have minus omega over 2L minus 2A at point C. Okay. Then at point C to D, we get P, positive P. So now we bring it back up to positive P. It goes to positive P, and then it runs horizontal. Okay. So this is where we get our positive P. And then for our bending moment diagram, minus PA, right? And then because of the slope, is positive slope, right? So this expression over here, we have px minus PL. Okay, so this is px minus PL slope. So px is positive slope, that's why it's going upwards. So when we know why I drew to 0 down here, because when x is equal to L, the bending moment is equal to 0. Okay, so this is how the shear bending moment diagram will look like. So the final point is at point D, right? At point D when x is equal to L. Okay, so again, we do from right to left analysis, right? So this is the datum. So I think now I hope you're convinced that you have to learn left to right, right to left. So this is L, V at point D, right? Moment at point D, right? So coming down at P, okay? So now we just apply static analysis. Positive is going up. So it could be minus P plus by V at point D. Okay, so V at point D is equal to P, okay, which we have. And then the moment, right? So moment at point D is equal to 0 because of no perpendicular distance. Okay, so that's it. Okay, now, so this is P. And then moment at point D is equal to 0. Okay, so we have constructed our shear force, and then we should, because P is coming down, as you can see over there, we just need to close this up. Okay, just need to draw a vertical line coming down. Okay, so what I'm going to do now is I'm going to look at the characteristic of our shear force and bending moment diagram. Okay, there are relationship, very interesting relationship. Some of you will know, some of you might not. Does not matter. I'm going to describe what they are. So I'm going to copy the whole thing. And I'm going to start a new page. So there's some very interesting observation to be made. Okay, and I'll tell you